Biocham. And we're back. Just like the title's read, I have to cross check my assignment that I submitted. Uh, yeah, I need to cross check it before the class, just like the title's read. I got about 45 minutes. Well, why is my headphone not turning on? Okay. So for I wanna know. One -3. Well, so the formula is from the first law of thermodynamics. First law of thermodynamics. And why PV applies only to gases, since solid liquid have negligible PV contributions compared to gases, so changes in number of moles directly applies only to gases. Applies only to gases. As solids and liquids have very slight PV contribution. Therefore, the changes understanding why reaction to after balancing negative delta N means the moles decreases during the reaction. Means system volume tends to shrink. Now for part C. Burn nitrogen down. What was the question? 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 Molar reaction. Molar reaction heat. Now, Haber-Bosch. So we have to find the molar enthalpy of N2O5. After considering equation number 1, 2, and 3, N2 plus 5 by 2 O2 gives N2O5. This is the equation this is how the reaction relates from nitrogen oxygen to nitrogen pentoxide or N2O5. What's the name for N2O5? Nitrogen pentoxide? Dinitrogen pentoxide, okay. From adding equation number 1 and 2, we get N2 plus half N2 plus 2 O2 gives 2 times NO2, and that would be resulting in 66.4 kilojoules in enthalpy formation for NO2. Now the same, we divide the equation number 2 by 2 to match the coefficients. Divide the second equation by 2, which results in a formula of reaction equation of 2N2 plus half O2 into O5. Here NO2 and NO2 are equal, so we add the reaction, which gives us N2 plus 2. Now the enthalpy of formation of N2O5 is the sum of these two reactions. That part I'm still confused. Now, for example 11, also, could you quickly explain what does it mean when delta H is positive or negative? I want to know. It's an exothermic reaction. Endothermic reaction, okay. Now example 11. For example 11, the CPM is heat constant. Heat capacity of shit. Those are heat capacity. Kirchhoff's law, according to Kirchhoff's law, what's the name? Reaction enthalpy. So change in reaction enthalpy of temp T2 is enthalpy of reaction at T1 plus integral of the heat constant, heat capacity. the integral of change in heat capacity. And heat change in heat capacity is calculated according to these using the stoichiometric coefficients, where delta Cp is 2 times heat capacity of NH3 minus which we would get about okay. Zero degree molar reaction enthalpy of Haber-Bosch synthesis. Haber Haber-Bosch synthesis would be having a reaction equation of 2 times N2 plus 3 H2 gives 2 NH3, and we'll be using the Kirchhoff's law to calculate the final or enthalpy change, molar reaction enthalpy at T2, or why did I turn? Why is the window still open? Fucking hell. That's what I was wondering. It's so cold. So cold that it should not make sense. That level of cold. Let me wash my hands. It's pretty cold. And the last question I just left, the enthalpy of combustion of a sebacic acid was measured using isochloric bomb calorimeter. I don't know if ChatGPT could even comprehend this question. I need deep seek. For example, could you repeat the equation used based on first law of thermodynamics? Also explain the terms involved in the equation. Of course, relation between H and delta U. First law for closed system. Constant pressure W, but a constant pressure. At a constant pressure, QP delta H. What is U? Internal energy change. Internal energy change. Internal energy change. Enthalpy change. Uh, inter and, and Should I write that? Maybe. First law for closed system in change in internal energy equals charge plus work done. Constant pressure. Work done equals P delta V. Q minus P delta V constant pressure QP equals delta H. P delta V, ideal gas law, P delta V equals delta NGRT. Okay, now that's how they get the delta U equals delta H minus delta NGRT. What's U here? 8:37. God damn, I gotta go to class. Oh no. Early morning. Yo, Clone Open Commander. Yeah, kind of. Early morning study sesh. More like rechecking. Because I have class in about 9:15. That is like 30 minutes. And the professor might ask me to present one of the answers. It's like random. He just picks someone in the class to do each question. And if I get picked, I need to present my answer. So I was just checking. What was he? Internal energy. That's internal energy. Change it into. Okay, that's internal energy. What's Q here? Q is heat transferred to the system. Work done on the system. Yeah. This is energy conservation law. Whoa. What is that? Who the fuck is that? Is that spam? What the fuck is this? Spam. Where do I click spam? Port spam. Yeah, how the fuck? How the fuck they got this number? Oh no. Oh no. Yeah. Definition of U, use the internal energy. Okay, so I got that one. Haber-Bosch equation, Kirchhoff's law. What did you do, DeepSeek, ChatGPT? Oh, did something. Did a lot. Oh, nah, it's okay, ChatGPT. I did not do that. So, for example 11, Kirchhoff's law is the equation like that, or do I have to show derivation? Also, why is the delta C PM uh, based on stoichiometry? Equation used is Kirchhoff's law. Yes, the equation mentioned is Kirchhoff's law. That's a standard form. Okay, that's good. What Kirchhoff's law means? Kirchhoff's law tells us how reaction enthalpy changes with temperature at constant pressure. Whoa, what the? With stoichiometry? Uh, no, I just need a answer why. Here, VI is stoichiometric coefficients for each species. So overall change in heat capacity depends on how many moles of each substance are formed or consumed. Okay, that's why. I'm kind of scared. Well, there is no point in being scared. If they ask you, I gotta just present, right? So YouTube, I think that's it for today. I just gotta, just get fresh, do some mates, maybe wash my face, and continue with the classes. We'll be back because I have to submit the sequence analysis homework. So I'm just gonna come back and do that. Peace out, YouTube. Don't, not peace out.